A set is an associative container that holds a sorted set of objects. The set class holds only unique objects, where the multiset class allows duplicates. Let's make a working copy of set.cpp, and we'll paste this into our working project here, and I'll double click on it to open it in the editor and compile and run. And I'll walk you through the code here. You'll notice on line 3, we include the set header file, and that brings in all the stuff for the set. And on line 9, we're declaring a set object, and this is a set of strings. And so we have string in the parameter list there, and we're initializing it using an initializer list, which is a C++11 feature. And on line 10, we use the size method to find the size of our set, which is 5. You see here in our results there is a 5. And then we're using the range-based for loop to step through the set. And you'll notice that the order of what comes out is different than the order that we initialized. And we initialized it as 1, 2, 3, 4, 5. And the order that's coming out here is 5, 4, 1, 3, 2. And that's actually alphabetical order. And so the object that's the basis of our set, in this case it's a string object, and so we have a set of string objects. The set container code is using the strings comparison operators in order to sort the strings. And so when we insert another element, and down here on line 17 we insert another element, and then we use another for loop to display them, you'll notice that 6 is now in its alphabetical place. 5, 4, 1, 6, 3, 2. Down here on line 24, we attempt to insert a duplicate element. And you'll notice that that insert fails because our set still has just our 6 elements, 5, 4, 1, 6, 3, 2. If you want to be able to test the return value of the insert to find out whether or not it was successful, you'll need to use a pair because the insert returns a pair. And the first element of the pair is an iterator, and the second element of the pair is a bool. So you declare the pair like this, pair, and we're going to declare an iterator here for the first type, and that looks like this, and a bool for the second type, and we'll just call this RV insert. So this is for our return value from the insert, and I can say RV insert equals, and now I'll get that return value pair. Because I want to just test the bool, I'm going to pull a little trick here, and I'm going to declare a bool reference. And so I use the reference operator, RV insert dot second, and that just makes a reference to the second element, and then I can test it more easily. I can say if success, I'm just going to call this insert success. So if insert success, and I'll take my for loop, and we'll print out our results, and I'll say else cout insert failed, like that. And so now when I test this, I'll press the compile and run button here. You'll see it'll say insert failed. If I try and insert something that we can insert, like a 7, save that and run it, and it goes ahead and it works, and now we have a 7 in our list there. We'll put this back to inserting a 5, and we're going to go ahead and insert that 5 because we have another type of set, you'll remember, that does allow duplicates, and this is called a multiset. So if I just change our declaration from set to multiset, now we can insert duplicates. Unfortunately, the return value from the multiset insert is not a pair. It just returns the iterator, and we don't actually need that, so I'm just going to get rid of all of this stuff here, and I'm going to get rid of our test for insert success and just put it back like this. And now when we compile and run, we're able to insert that 5, and there it is. Now we have 2 5s, 5, 5, 4, 1, 6, 3, 2. And obviously it doesn't matter which of those 5s is which because they're both the same. And then finally, after inserting things, you sometimes also want to delete things. And in order to delete something, you need to be able to find it. And so there's a find method, and there's an erase method for deleting an element. And so the find method on line 31, it returns an iterator, and here we've declared a set iterator. We actually have a multi-set now, so we can change this to multi-set, but you'll notice that set works. It's always best to declare it correctly. Or you can use the new C++11 auto keyword, and this will simply declare an object of the same type as whatever is on the right-hand side of the assignment. And so in this case, it will declare it as the correct type of iterator. So auto is a really great feature in C++11, and this is exactly the sort of situation that it's good for, because otherwise you just have this very long and rather complex, and they can get even longer and more complex sometimes. Remember how our pair looked? And so auto is actually a whole lot simpler. So I'm just going to put an auto in here. And so if it's found, it will not be equal to end, and if it's not found, it will be equal to end. And so we test for the iterator to be not equal to end, and if that test works out and it's not end, then we've found it and we can go ahead and erase it. On line 34, we erase. And if we don't find it, then on line 36, we print out not found. And we go ahead on line 38 and we use the range-based for loop to print out the set again. So let's go ahead and we'll run this one more time, and you see that it works great with the auto type, and it found the 6. And if I change this to a 7, which it won't find because we did not insert the 7 above, there's our full set on the line above there, then I can save this and run it, and you see it says not found, and it didn't delete anything. So sets are useful in cases where you need an ordered set of objects that you can search, but you don't need random access. Use multi-set if you need duplicates. Now let's delete our working file and run clean to get set up for the next lesson.